Hi everyone, my name is Ramtin, and I'm here from a story team. I am blockchain tech lead at a story, and I'm gonna talk about what's next for a story's blockchain. I know we launched the story blockchain less than a year now, almost start of this year, but we're already talking about what's coming up next. Okay. So as you know, we should be really good at the storytelling. So I will tell you the story of what's coming up next. I will break my talk into two parts. The chapter one, what we did before, after launch, and the chapter two, what we are working on right now, which is going to be released later. So I call the chapter one the solid foundation. Sorry, there we go. And the solid foundation is what we did before. It has two goals, right? At the start of this year, we had two goals: building a solid and secure foundation for IP, and also seamless onboarding and integration of early adopter ecosystem applications and anyone else who wants to use IP. So we achieved a couple of items at the start of this year. First, but definitely, we spent some time design and develop Stories L1. So Stories L1, if you don't know, is a purpose-built L1 blockchain. We benefit from something called multi-core architecture, which allow us to do and optimize the environment to handle large, complex IP graphs, which we call it IP core. Later after that, earlier this year, we launched mainnet, which the best part was we kick off with a diverse set of top-tier validator, a big portion in Korea. And then we also did consider fair ecosystem bootstrapping. The main reason, we spent a lot of time making sure we launched the network with the very right set of validators, because we want to make sure the uptime is really nice, there's no hiccup, and we can onboard everyone without any problem. Also, we spent some time to make sure we don't actually introduce breaking changes. This is the hardest thing that anyone can do, because we were excited to build more and more and just launch new changes. But we know that early days, you want to do not disturb any ecosystem product to launch on your network. So we minimize the amount of breaking changes. We make sure that the network is 100%, has 100% uptime. And we started improving the developer experience during that time. After that, we start working on basically securing this foundation. Now we launched the network, we formed the security council, we start doing a lot of audits. We had the bug bounty program. There was a lot of interesting potential or future vulnerability was reported, so we fixed a lot of those. There was a lot of client upgrades. And definitely something that everyone was super excited for, it was the recent upgrades for Pictor upgrade that we rolled out very early days after Ethereum upgrade happened. We already working on Fusaka upgrade, so stay tuned for that part. And the very last thing we did in this chapter one was increasing number of validator seats to 80, because we want more validators to participate. And also we have to, during that process, we have to optimize the consensus to minimize the latency or maintain the latency to the numbers we want. This was just a short summary of everything we did. Now I'm more excited to talk about chapter two. So chapter two is what's coming up next. I call it opening new doors. So the very first door that we are opening basically has two goals. The very first one is we need to still maintain the network with the level of excellence that we want from liveness, performance, and safety. We will continue doing that. But at the same time, we want to start adding new features and adding new functionalities to the network that will basically align with the vision of chapter two, AI native vision that was shared earlier by Andrea. What does that mean? So IP Vault is the very first door that we are actually building it right now. And it's about secure, confidential, programmable access to on-chain IP data. So what is basically, let's walk back. What does power an IP on a story? So under the hood on the L1, you have multiple things. First, you have a native support of IP assets. So IP asset, like in order to be able to tokenize the IP assets at a scale with the performance you want, we natively support IP assets, right? Then you have the options to compose assets, like build new forms of IPs by composing the previous IPs. We call these IP graphs, right? And these IP graphs are a very powerful tool. Basically, you group the previous IPs together, you combine them, you remix them, you do a lot of functionalities, and you can form new forms of IPs. And these graphs can actually go really big, can be really huge, can be many layers of depth inside it. And then we definitely optimize a lot of functionality to make sure that this matches the reality or requirements on the real world. Third, you have programmable licensing, which is the PIL framework, we call it. It's basically your IP, your terms. You define what exactly is the rules, what is the functionality of this IP, how do you get a license of this, all the terms, payments, everything else is part of on-chain enforcement. And then we also have on-chain functionalities for attribution and everything else. Using these graphs and the framework that you have, you can see you can have automatically royalties from these different parts of these graphs coming to you. Okay, now we are upgrading this. We said that you have all of these functionalities for your IP on-chain. Now you can store confidential data alongside your IP on-chain, which means that any IP now has access to a very secure vault attached to it that can actually hold some data on-chain at a scale. I will get to this. This data can be, you can think of it, can be a AI training data, it can be a digital asset, it can be a biomedical data, it can be anything that can be an IP. Okay, so let's walk first about the goals. So our goal is basically solve this problem with these constraints. We want to solve this to be programmable and be attached to the IP. We don't want any solution that is not relevant to your IP, for example, store it somewhere else and then just reference it there. We also don't want to sacrifice decentralization or confidentiality or safety. This data should not be revealed to anyone. It should not be stored in any centralized location. It should not be at risk at any time. So basically your IP, the IP's data, it has to have the same level of security as your IP asset on chain. And then at the same time, we also want to consider user experience. A lot of time, these secure storages, you have major problems with the user experience. A lot of times you can see that you store something somewhere else, you have to pay with a different currency, you have to wait for synchronization between different networks. So we want to make sure that the storage onboarding is a perfect case for the users. So for all of these things, we start designing IP vaults with these goals. So basically, IP Vault, as I mentioned, is a secure on-chain storage space that is attached to your IP asset. It enables automated access to the data based on IP ownership and IP license. So you can think of it, the IP owner, when it register an IP, it has the options to secure upload the data to the vaults attached to the IP. And for doing this on-chain, they only need to provide the proof of ownership of IP. So they will say oh, I own this IP, so I have the right access to this vault. And the IP buyer, whenever acquire a license, automatically get access to the information in this vault. It is built by the same multi-core architecture that I was talking before, but we are basically adding a new core to this architecture, which is powered by the trusted execution environments. I will get into more details a little bit later. But at the same time, is still compatible with what have like existing data availability layers. So the existing one can still be in use, and I will show you how this is going to work. So behind the scene, we are allowing the validators to opt in to participate in IP Vault, and the way it works is these validators will contribute to the IP Vault, safety of IP Vault, and receive extra rewards for doing this. They basically register their TE environment to the IP Vault's core contract. So this is a smart contract that is deployed on a story and facilitates synchronizations and communications between these TE environments. The data itself, it's never stored on any of the single machines of validators. It's basically secret shared between different validators, and you can think of it as not even like accessible by the validator itself, is inside the trusted execution environment provided by the validators. So the smart contract in the center is responsible for synchronizing, facilitating distribution key generation, DKG, between these TEs, and basically any operation, like for example, whenever you have to decode an IP vault for a new user, they will collaborate within this smart contract to perform threshold decryption. There is a lot more details about this, but I just want to showcase like on a high level how this is achieved. This means that the data is only accessible by the IP owner and the license holder to the IP. No one in between can see the data, and it has like a same level of guarantees, even more than the network itself. So if your IP asset is secure, the IP vault also benefits from the same level of security. Let's walk through a simple user journey here, then I will wrap it up. So as I mentioned, the IP owner will register the IP, it can create this, and then it will attach a vault to the IP, and then the IP buyer, whenever acquire a license, automatically get access to the contents of this vault. This is very important because there are multiple details in this. First of all, you don't need synchronized action by IP owner and IP buyer. So they can participate based on their own timeline. You can think of it, the IP owner registers the IP, uploads the data, and can leave the network. And then later on, anyone can acquire a license to the IP and get access to that data, and this can be at any scale. So you can think of many IP buyers can later on acquire this without any interaction from the IP owner. Besides this, we are introducing a new concept which I'm really excited for, which we call it conditional decryption. So conditional decryption allows the IP owner to define an extra conditions for how this IP vault is accessed or decrypted. Basically, I am the IP owner. I can set up the rules that I say, besides getting a license to my IP, you need to satisfy these conditions in order to get access to the IP vault. And this condition, for example, can be providing an instance of trusted execution environment that is running very specific code. In other words, I can limit the functions that can be run my IP's data. I can limit, I can time bound the access to my data. I can do a lot of conditions that can let you protect your data or limit what is the use case for the IP's data. Let's walk through an example here. In this example, you can see there are many people out there. Each person, let's assume each entity, they register IPs, they have a small subset of training data, and they register them as IPs, and they upload their data in the IP vault. At the same time, you have another user that registers their own model as part of IP as well, and uploads this model as IP vault, inside the IP vault as well. They can define a condition that whenever anyone wants to get this license, these data, all the data sets, and the model only gets unlocked inside the TE execution environment, trusted execution environment, and only specific operations such as fine-tuning can happen on this data. and the results automatically register as a new form of IP. So you can enable, besides the storage, you can actually enable trustless execution over the data as well and define those conditions. We think this is a very powerful concept. Like, many applications can benefit from this. A lot of applications from our ecosystem are already looking into how they can benefit from this and how they can use this. And currently, the IP vault is in the development, and the mainnet release is, the DevNet release is scheduled for later this year, and with the hope that the mainnet will be released next year. The mainnet is going to be released with a lot of ecosystem applications launched on the day one. That's the plan. And IP Vault was just one example of the Chapter 2, the features that we are building for Chapter 2. There's more in the pipeline that I didn't get a chance to talk about. But the best part is we are a decentralized blockchain team building the infrastructure for a story. Many of us are here right now today in this room, and please come talk to us if you are interested or you have any question. Thank you.